experimental measurements of G, the universal gravitational constant, have been a fundamental part of modern physics and have played a crucial role in our understanding of the universe. G, or the gravitational constant, is a fundamental constant of nature that represents the strength of gravitational force between two objects. It was first introduced by Sir Isaac Newton in his famous work Principia Mathematica, where he described the laws of motion and gravity. Newton's laws of gravity established that the force of attraction between two bodies was proportional to their masses and inversely proportional to the square of the distance between them. The value of G was not determined until more than a century later, in late 18th century, when Henry Cavendish conducted an experiment to measure the force of gravity between two masses. Cavendish's experiment involved suspending two lead spheres on a delicate torsion balance and measuring the slight twist in the suspension wire due to the gravitational attraction between the two spheres. Using the observations, Cavendish was able to determine the value of G within a few percent of its current accepted values. Since Cavendish's experiments, numerous other techniques have been developed to measure G. Some of the most commonly used methods include torsion balance experiment, beam balance experiment, Schiehallion experiment, etc. In the torsion balance experiment, a delicate balance is suspended by a thin wire and two large masses are positioned near it. The gravitational attraction between the masses causes a small torsion in the balance, which is detected as a twist in the wire. By measuring the twist, the force of gravity between the masses can be calculated and the value of G can be determined. In the beam balance experiment, a balance is used to measure the gravitational force between two masses. The balance is carefully calibrated and the masses are positioned in the opposite end of the balanced arm. By adjusting the position of the masses and measuring the deflection of the balanced arm, the value of G can be calculated. The Schiehallion experiment, conducted in late 18th century, involved measuring the deflection of a plumb line due to the gravitational attraction of a nearby mountain. By comparing the deflection of the plumb line at different locations around the mountain, the mass distribution of the mountain could be determined and the value of the G could be calculated. Despite numerous experiments over the years, the value of G remains a most unconstant fundamental constants of nature. This uncertainty due to the difficulty of accurately measuring the tiny gravitational forces involved. In recent years, efforts have been made to improve the accuracy of G measurements using new techniques such as atom interferometry. Finally, the experimental measurements of G have been a fundamental part of modern physics, providing insights into the nature of gravity and structures of the universe. From Cavendish's torsion balance experiment to modern atom interferometry techniques, the measurement of G have been a challenging and fascinating pursuit for physicists over centuries. While the value of G remains uncertain, efforts continue to refine the understanding of these fundamental constants and its role in the universe. So thank you for watching this video. We hope that you found this information informative and helpful. If you have any questions or comments, please feel free to leave them down below. Don't forget to like and subscribe to our channel for more videos like this, and also don't hesitate to share this video with your friends and family who might find it interesting. Thanks for tuning in, and we'll see you in the next video.